Ever wondered why it's so much harder to start pushing a heavy shopping cart than it is to keep it moving? Or why your coffee spills over the rim of your cup when the car stops suddenly? These everyday experiences can all be explained by the laws of motion, first penned by Sir Isaac Newton over 300 years ago. Take the first law, the law of inertia. Imagine you're at a bowling alley. When you roll the ball, it continues in a straight line until it hits the pins or the gutter. That's inertia in action. An object in motion stays in motion, and an object at rest stays at rest unless acted upon by an external force. In this case, the external forces could be the friction from the floor, a collision with the pins, or the unfortunate rendezvous with the gutter. Next up, the law of acceleration. Think back to that heavy shopping cart. It was tough to get it moving, wasn't it? That's because the amount of force you need to move something is directly proportional to its mass and how quickly you want to move it. A larger mass, like a loaded shopping cart, requires a greater force to accelerate. And if you want to start sprinting with that cart, you'll need an even larger force. Finally, the action-reaction law. This is the one that explains why you might jerk backwards when you fire a water gun, or why a skateboard rolls backwards when you jump off it. When you exert a force on an object, that object exerts the same force back on you, but in the opposite direction. It's a cosmic game of tit for tat. So, in summary, objects like to keep doing what they're doing until something makes them do otherwise. That's the law of inertia. The force needed to move an object is directly proportional to its mass and acceleration. That's the law of acceleration. And for every action, there's an equal and opposite reaction. That's the action-reaction law. These three laws of motion govern everything from the smallest particles to the largest galaxies, and yes, even your morning coffee.